Hi everyone, we're Team 5G.11 and our platform is about creating the next generation of 911 response. A quick overview of our team, we have John, Jordan, and Tanjun Ming, who are our lead engineers, and Jia and I, who work on the business strategy. So we live in a world with a very inefficient 911 system, and these inefficiencies create costs and problems which burden both telecom providers and emergency response teams. On the telecom side, we estimate that telecom companies incur about $960 million in annual costs to provide 911 calls and the associated infrastructure across the country. Secondly, millions of dollars of fines are charged every year by the government for 911 call misconduct and issues in the active infrastructure. Thirdly, the states are planning to only enforce stricter regulations and requirements, which imply higher costs in the future. Lastly, there are rising questions of whether charging customers for 911 call services in some states are ethical or not. On the other hand, emergency response teams run an outdated and inefficient process. Firstly, surprisingly, even in 2020, dispatchers are unable to accurately track the location of calls from mobile devices relative to those coming from landlines. Dispatchers also have very limited information flow across agents because voice communication remains the only real medium of communication. Lastly, multiple emergencies are reported later than optimal, creating unnecessary additional costs in the emergency. We believe that the 5G.11 platform is the future solution because of its ability to help preemptively detect emergencies, allow for better emergency response, and create significant cost savings to complement the current 911 system. This is achieved through new technologies in 5G, AI, and IoT devices.
I will now take you through an overview of our solution, which comes in 5 successive stages. In the first stage, we propose the use of a network of IoT devices capable of measuring environmental variables, such as temperature and location data. So these devices are linked to our backend analytics system, which will trigger an alert whenever an emergency is detected based on the data measured. When an alert is triggered, we move on to the next stage and notify all relevant agencies, such as the fire department and the local police. The platform will also concurrently start an assessment and preparation of a plan to deal with the emergency based on the current available information. The relevant agencies will then respond by deploying various assets, progressing us to the next stage. While these deployed assets are en route to the emergency site, our platform provides a real-time situation overview by tracking the location of each asset. The platform is then able to provide support, such as supplying routing information generated based on real-time traffic conditions. When these assets arrive on scene, they will provide additional sources of information to our platform through devices such as helmet-mounted cameras worn by first responders. Combined with pre-existing sources of information such as building layout and satellite imagery, our platform has a comprehensive view of the entire situation on the ground and is able to provide critical advice and insights to help first responders deal with the emergency. When the emergency is resolved, our platform consolidates all information and data pertaining to the emergency and stores this as valuable information securely. This data can then be used in the future as a guide for management of emergency situations or to serve as evidence for insurance claim.
So now we'll move on to a live demo of our prototype, and we'll be bringing through the life cycle of a fire emergency. So let's now take a look at the IoT device first. So this is actually a simulated IoT device which will send information to our system periodically. And our system will actually utilize predictive analytics to predict if there are any potential emergencies. So let us now say that our IoT device registers a sudden spike in temperature. And this actually represents a very high likelihood of fire, right? So our command center will now see this alert at the dashboard, and the personnel in charge can then click on this alert to view more details. Yep, so this actually shows the first stage of our fire emergency response. The dashboard actually shows the overview of the fire, like the location, number of people, and the category of the fire, just a few to say. And at the same time, the system will also trigger the emergency alert system to notify all nearby residents to leave the location of the fire. and alert the nearby fire stations at the same time. And in this case, it will be the Berkeley Fire Station number 5. So when the fire station acknowledges, we'll move on to the next stage of our fire emergency response. So in this stage, our platform or system actually recommends a set of assets to deploy based on the perceived severity of the fire. The command center will then send these recommendations to the fire stations, and the fire stations can make their own judgment based on their own experiences.
And yeah, so right now we are in the dispatch stage. As you can see, we have a full-on map view of the fire engine actually moving towards the KL Memorial Stadium, which is the fire location. As you can see, based on our analytics, we actually avoided an accident along Derby Street as we took the path. And that's because we have a real-time analytics engine to actually notify the fire engine on which route to take and which is the most optimal path to take during the whole process of the dispatch phase. As you can see, we have all our assets deployed right here. And upon reaching the location, the fire engine and the fire staff, they will actually notify the command center that they actually reached the fire site, and we can move on to the next stage, which is the mission stage. And so moving on to the mission stage, this is a stage whereby we have an overview of all the IoT devices of all individual firemen, and we can track their location as they are doing their duty. And as well as we also have the rescue information of various people that we require to rescue. For example, label A, which is in a certain location, for example, level 4 and room 2 of the KL Memorial Stadium. And with this information, we can actually guide the firemen to actually properly take certain rescue plans, as well as to properly guide them during this whole fire mission. And on top of that, the command center also has a view of all the IoT information from all the firemen. And this is just a simulated view of the camera footage of what could be seen from the command center. And with all this information, the command center can better provide information during the mission and better provide guidelines as well as guidance while the mission is taking place. So after the mission is ended and all the people has been rescued as well as the fire has been fought off, the fireman leader will actually send a notification saying that the mission is over, and we will actually move on to the next stage, which is the post-accident. And this stage is where we actually log all our activities that happened in the fire, be it the route taken, what assets were deployed, as well as what are the key information such as casualties and injuries, as well as the video and log files of the entire mission. And this will allow us, as Jiming has stated, to actually provide better analytics for the future fires to be fought. And so that's all for our demo. And now I hand over the time to Jiatang to further explain the business proposition.
So we would like to start off by partnering with companies like Amazon and Google to access to their IoT devices and get their data so that we can trigger the detection process. At the same time, we want to build partnership and share data with emergency providers, such as fire stations and medical centers, to have that kind of data exchange. And after the whole system being developed, we want to implement in several cities with 5G coverage to start off. And hopefully in the long run, IoT data analyzing and sharing can become the trend for the whole industry. And 5G.11 can gradually take on more market share as the industry developed and replace the current 911 with our more predictive and more well-rounded system. This slide will show our team learning process. As you can see, we have been through 6 different phases. So initially, we were thinking about video-enabled emergency alert app, but after the first few classes and discussing with the professors, we decided to add more features in the light of the 5G technology. And then we kind of narrowed down our focus to the IoT technology and how IoT devices can be incorporated into our system. Then our MVP will become how to understand the IoT and how IoT can be used to predict and detect emergency situation, and how to technically manage the whole process, like the 5 different stages we mentioned earlier. And after solving the technical issues, we move on to the business aspect and to see how our product can be fitted into the market, like how to reduce the burden on telecom providers and how to better help the public to reduce unnecessary time and money cost. And last but not least, we want to summarize that the project was building on some technical basis that we require a world with more and more IoT data available, and we definitely want the 5G to have high speed and broader coverage. And also for the receptivity, we need to form in partnership with IoT companies, as well as we require responders to work with 5G.11 for the two-way exchange of data and information.